All right, so last time we talked about the basics of like how to set up a significance test. Today I'm going to do a quick review and then actually conduct one test, okay? So the p-value, of course, is a conditional probability. Again, we talked about all this part last time. Conditional probability. It assumes the null hypothesis is true. Assuming that the HO is, or the H naught is true, then the p-value measures how likely it is to get evidence for our alternative, okay? Because remember, we're testing for our alternative. And we want to look to see if it is as large or larger in the direction of the alternative. Okay, and we determine whether it's by chance alone or something else is at play. So remember, we have to name the test. Okay, which in this case, it's going to be a one sample z-test for proportions. Okay, or you can write down the generic z formula, which we're going to get to in a second. Okay, which was that z equals all that stuff. Okay, so then remember we have to check some conditions. We have to check to make sure that our our number of successes are greater than 10 and number of failures is also greater than, not p hat, sorry, that should be a p naught, sorry. Okay. And then for the confidence intervals, we also have to check our p hats. Same thing. So p hat greater than 10 and the number of failures for our p hat is greater than 10. Okay. All right. And then just a reminder, when there is not convincing evidence to reject our H naught, it does not mean that it's true. We never say we accept it. We just say that we fail to reject it, okay? So just a couple reminders again, 4 steps. First, we have to communicate. Okay, like what is our P in actual words, and then identify the different hypotheses. So again, you'll have, your HO is P is equal to something, your HA is P is less than, greater than, or not equal to, all that stuff right there. And then also write down your significance level, your alpha. Okay. Then, like usual, check your conditions. And I'm not going to waste any time going through that again because we've done that, 1,000 times. And then we calculate. Okay. And remember, this is a one sample z-test for proportions. Okay. And then you can either write that whole thing out, or if you include the formula, that would be enough, which in this case for our z, or for our test statistic, that's p hat minus p naught over the square root of p naught, 1 minus p naught over n. Okay, either of those would be sufficient. Okay. All right, then you're going to find your p-value by calculating the probability of getting that z statistic. And then that's where we use that normal CDF. Okay. And then finally we conclude, and this includes that nice just script that has all the things that you have to fill in the blank with. Okay. All right, so let's look at an example. Okay. So go ahead and read this real quick, and then we will run through all the steps. All right, so first up we have to identify everything. So let's see, P in this case is going to be our proportion of students who have a computer at home. Okay. And then our null hypothesis is, let's see, Alan reads a report that says 80%. So that means P is equal to 0.8. Okay. And our alternative, what does he believe? He believes the proportion is smaller. So we're going to do P is less than 0.8. Okay. And let's say he chooses to do this test at a 5% significance level. So that means our alpha is going to be 5%. And let's see, he's doing a sample of 60 students. I'm also going to write my n down, and he says 41, say yes. This means p hat's going to be 41 over 60, which is 0.683. All right, and that is all the variables I will have to use in this problem. So next up, check our conditions. Is it random? Let's see, SRS. So SRS was taken. Is it independent? We have, let's see, is our N less than 10% of all students at the school? Okay, and I'm going to say it's a safe assumption. Okay, and then is it normal? Okay, and that is checking our successes being greater than or equal to 10 and our failures, which is going to be 0.2 greater than or equal to 10. And both of these do indeed work out. So we're good to go there. Okay, so now we've communicated, we've checked our conditions, and now it's time for calculation. So we're going to use a one sample z-test for proportions. Okay, and I'll also write down the formula here. Got a z is equal to p hat minus p naught over square root of p naught 1 minus p naught over n. And then we fill that in with the variables that we have. P hat was 0.683, P naught was 0.8, and then the square root of 0.8 times 0.2 over an N of 60. This gives us a Z of negative 2.27. Okay, and again, if we want to draw that out, we have our 0 here, we've got negative 2.27 over here, and we want to see what is less than. Okay, it's going to be a normal CDF with a lower end of negative 2.27 and upper end of, sorry, got that wrong, got that backwards, I knew something was wrong there. Our lower end is negative infinity, and our upper end is negative 2.27, sorry about that. And then our mean is 0, standard deviation of 1. That gives us a probability of z being less than negative 2.27 of, comes out to 0.0116. Let me double check that. Where's my calculator at? Let me slide that over, bring this back. So let's see. Normal CDF. Negative infinity and negative 2.27. Yeah, there we go. Just want to make sure I had the right number. All right, so there is our probability. Okay, and then we check that against our alpha. So this is about 1%, which is less than 5%. So because our p-value is got to state our p-value. Our p-value of 0.0116 is less than our alpha of 0.05. Remember, if it's less than, then we reject. We reject the null hypothesis because we have convincing evidence convincing evidence that the true proportion of students who have a computer at home is smaller than 0.8. All right, so again, that's just a fill in the blank thing. All right, you can also do all of this with the calculator, okay? On a free response, you're gonna have to write all this out, so it's not like you can just, skip over knowing how to do this, okay? But it's just like on a multiple choice question, go with the calculator, okay? So when you go to that, we go to we go to stat this time, and you go to tests, and we're looking at the one prop z-test. And then it's going to ask you for a couple things. The P naught is, of course, going to be the claimed proportion, which in this case was 0.8. Okay. The X is going to be the number of successes. okay, which in this case was 41. And then an N is the sample size, which in this case was 60. And then it's going to ask you to highlight one of these. Okay, so this is basically how many tails are we going to have in which direction. So got a two-tailed, got a less than, and a greater than. Okay, and this one was, we were doing less than. Okay, and then we want to calculate. And then it gives us a lot of information. We're going to talk about like what the color means probably later. That's for like graphs, and we don't really get into too far into that. But anyway, so it gives you all this information, tells you like which direction you were going, and then your z value, your test statistics, your p value, and then your p hat and all that kind of stuff. Okay, so for this one, we end up with, it says interpret the p value in context of the problem. So if the true proportion of students with laptops, get that out of here, laptops at home is 80%. Okay, so that means that's just the claimed value is 80%. So then the probability that a sample has 41 or less out of 60 with a computer at home is 0.116. All right. So there we go. So again, that's just sort of the definition of like p-value and what it means in the context of this problem. Okay, so that's it for this set of